My name is Momen. I'm a senior penetration tester and a red team operator at Samurai Digital Security. And today I'll walk you through this concept of stealth network exfiltration and commanding. As we know, in our world right now, the cyber attacks are actually essential part, for example, for the most wars or even just like attacking other people in other countries without specific reasons. Here, for example, you can see a lot of statistics from people are doing actual cyber attacks, for example, against OT infrastructures, against IoT devices, exploiting, for example, Cisco vulnerabilities because there's an actively exploited Cisco vulnerability right now. It's a critical 0 day, by the way. Even though these attacks sometimes are not being detected, and it's specifically by the threat actors that they don't want to get detected because they want, for example, to persist, or they just don't want to get out of the network, or they just don't want their tactics, techniques, and even procedures to be known and to be have like a signature, for example, in some online databases or online authorities like MITRE, AT&T, and CK, for example. So this is actually from the black side, from the evil side. But for red teamers, for example, the good guys, the white side, we need to be stealthy, and we need actually to remain silent during any network activities. For example, we are doing any command, we are actually executing remotely from other devices, etc., because we have an approach. For example, let's say we are in an Active Directory environment, or even in just like a Linux environment, a Linux farm of devices, for example, or just a farm of IoT devices. And inside this network infrastructure, there was an IDS. It was monitoring the network, seeking for any like possible signature, etc. Okay, but we don't want to get caught because our main objective is to just hit the master or the head of the IoT devices. For example, I've been involved before in an assessment against radio IoT devices. It was a farm of the radio IoT devices. And the main goal was to compromise them all and control them all as botnets. They wanted to know if this is like a possibility to happen or not. Okay, so just imagine if you just get caught after the first, the second, or even the third device. So it's not gonna be that possible for you to continue because the whole security team, as well as the security solutions, will be more aggressive right now for any weird network activity. So you have to invent and to think about a new way that makes you invisible during operations and at the same time makes you invisible during your just like engagements, because invisibility and being stealthy in red team or in the offensive security side is now a crucial part of our field. So first of all, maybe some of you will not even understand the term exfiltration or data exfiltration, and it's completely okay. So data exfiltration simply is the way we transfer data from and to the compromised device. For example, let's say that me as an attacker now, like let's say, just gained access to a device, and after gaining access to that device, I discovered a lot of important data that even this data may be exploited against the well, the device, sorry, the company or the organization or even the individual itself. Okay, so for example, if I was in a Fin group, so the first thing that I'm gonna do is simply just like transferring, for example, the whole backup from my current network or from the current device to another device or even to another cloud-based instance, for example. And to do this, okay, it will be something a little bit hard because, first of all, the amount and the size of the data will be a crucial part and a crucial like a crucial party of this of the calculation of what can we do and what we can't. So we just need to think about it more and more. Because, for example, if we have like 100 gigabytes, okay, and we want to transfer it, even though if we'll persist for let's say more than 1 month, for example, okay, but at least transferring this amount of data will cause huge noise in the network. Okay, so we do need to find a way that allow us to transfer the whole data, but without losing it, and at the same time transfer it without losing the access to that device. Because, for example, if I want to like deploy ransomware, the first thing I'm gonna do is simply having a backup from the data because I want to have like something to get my back. For example, if they didn't pay. Okay, this is from the threat actor point of view. So to achieve all of this, the only thing that you have to do is simply to find a way to do it without being detected or even without being kicked off from the network or even the device. Okay, to do this, you will need the term or the concept of data exfiltration. You will need to exfiltrate the data, but without being detected. So, in most cases, and actually in the previously used data exfiltration techniques, it was so noisy and at the same time so dangerous. Because simply, for example, if we're going to talk about it, previously the DNS data exfiltration was so common, and now it's like the first place where threat actors and threat hunters are actually looking to. For example, like exfiltrating the data through the CNAME record, for example, for a local DNS server, or even just like transferring it by requesting, let's say, a web application, and instead of like just requesting a legitimate subdomain, okay, you will simply request a subdomain which will be, for example, an encrypted data in a base64 format, okay, which simply will be also detected nowadays because nowadays we have, for example, the artificial intelligence, the machine learning, and all of them are crucial parts now from any security solutions. So it was noisy and dangerous. And also, I said before, for example, previously there was MQTT based data exfiltration, and it was good to be honest for command and control, for example, IoT devices, etc., etc. But just let's think and just let's assume if I was in an infrastructure that does not even support MQTT, so that we like having the appear of MQTT protocol or MQTT packets being sent from and to the network, it will be so suspicious. It's gonna raise a lot of red flags. So it's also have its own benefits, but at the same time, there are a lot of disadvantages that may harm you or even destroy the operation that you are in. When it comes to the data exfiltration, there is no specific way to do it. The concept that I'm gonna tell you right now and explain it for you right now, well, it's actually just a way like behind millions of way that you can exfiltrate the data with. And this is simply because there is no something specifically called this is the only way to do data exfiltration. You can do, for example, data exfiltration with your own way. You can take, for example, my way or my algorithm right here and just develop it to suit like the target system, the target infrastructure, the target network that you are working in, or even just develop it because you're seeing that there's something better can be implemented. And after that, simply have your own way of exfiltration. So there is no actual way to do it. It's just the way that you are thinking that it's gonna be less suspicious in the network or in the activity that you are doing right now, and you just want to implement it. The code is already in GitHub right now, actually. It's published since, I don't know, since maybe 6 months or something like that. I can't remember, to be honest. But it's already there in GitHub. recently uploaded. So you can just go there, pick the code, test it, analyze it, and then like analyze the algorithm and simply develop it if you want. Now, what is the WCE? You may heard me repeating WCE a lot. So the WCE simply is just a short term for Window Commander and Exfiltrate. And this is simply because I'm using here and exploiting the nature of the window TCP flag. For the first time you read it, you will just think, okay, so basically it started by like having the concept of transferring or commanding network nodes through window flags, for example. But to be honest with you, I started this concept and this algorithm just for data exfiltration because for the first time I wasn't even thinking about commanding network nodes. All what I was thinking about, okay, now I want to exfiltrate data. Let's say, for example, I want to exfiltrate like private keys, passwords, etc., configuration files, and network topologies, for example, databases, just like that. I don't want to even command a network right now. So I invented this algorithm or created this algorithm. But now, if you just give it another think, I was also thinking at the same time in the background, okay, so what if I just want to command a network or just to command a network device? How can I do it and at the same time being stealthy? I know that there is a lot of stuff that you can do. For example, just using secure protocol or unencrypt your traffic, etc., etc. But here I'm actually thinking about something that will not even be detected because there is no actual connection. So the impossible question inside my head was how to connect and command a network without even connecting to that network, without having a session established with that network, without even having any interaction with that network device. From the first time you hear this, you will think, okay, that's crazy because you cannot even connect with the device without even connecting to it. This is gonna be something this is just gonna be something crazy and it is not even applicable to be applied. And this was my thinking actually, to be honest with you, in the beginning. But after just like specific consideration in my head and planning, I was able to do it. And we'll see together how it works here. For example, we'll first of all, in my whole operations, I always avoid exploiting, for example, the known stuff that is actually exploitable. For example, I have a direct way of attack. I always search for an indirect way to attack because the direct way simply is always the expected way. And being unexpected is your key to be successful in any operation. So, for example, when I thought about controlling and commanding networks, the first thing you may ask about, or you may even think about, okay, so maybe we're gonna use something like HTTPS, for example, to route our traffic, or even using like, let's say, CDN, so we can, for example, rotate our traffic, or using the tool networks, etc., etc. Also to rotate our traffic before even commanding a network node. And all of these stuff are actually cool and all of this stuff may work. But all of these stuff are not normal. It's just something not intended to be in a network or a network infrastructure or even a network system. And this give us another angle. So are we going to be stealthy doing this? It's actually going to be one side. We are going to be stealthy because maybe nobody will know who are attacking us. It's just an attack happening. We cannot reveal the attacker. But from the other side, you are not stealthy at all because simply there is a knowledge or a pre-knowledge of an attack happening. So you are anonymous, but the attack is not, which is not 100% good practice to do. So it's always good to be anonymous and also to cover your tracks and to cover the currently running operation. And to do it, I'm always doing the term exploiting normal and intended stuff. So exploiting normal and intended stuff simply, I'm just seeking for the normal stuff. the normal, let's say, technology, the normal activity, the normal, for example, protocols, and then I'm just start thinking, how can I exploit it? Let's say, for example, we have the TCP, and the TCP is like simply a protocol, and because the TCP is a protocol, and specifically in our currently known TCP topology, there is a lot of flags inside it, and each flag got a specific function and a specific operation to do, and it's, or even just like flags just to give you like an information just about the host or something like that. Okay, so the first thing that I'm thinking about is, what is the most accessible flag or behavior? Which means, for example, what is the most viewed and seen flag that the whole, for example, let's say network monitors or even the security analysts look into. For example, the payload, for example, which could be the payload segment or part of the TCP packet that will hold your data, and maybe also the communication flags, for example, which is the connectivity flags like the SYN, and ACK, and then the FIN, etc., RST. All these flags are also monitored just to, for example, check if there is like a denial of service or port scanning, etc. But for example, having something like the window flag, nobody literally will just even think that there's something bad will be there, because the window flag, as we know, is just a flag that tells you and even show you the real size of the data that is actually being sent in your packet, which means simply nobody can even do anything with that port. And from here, I started to do it. Exfiltrate simply in the wind, no actual connection to any device, literally nothing, but from the compromised device only, one request or one packet or even two, okay, will be sent in order to execute a specific script under privileged access. After this, I don't even have to be there, because I will simply control from there, or from that stealthy way. I will have no actual connection with there. I even can jump into processes or even hijack processes to interact with that host, the compromised one, run this script from the same session, the same host, etc., and then just maybe run it as a service, put it as like a cron tab, or just like continuously running service, etc., to receive, for example, the specific algorithm that I'm using, or I'm spreading through the network, and simply just executing it. Okay, from the beginning, it may be a little bit confused. Like, okay, you may be a little bit confused, but everything will be clear right now. Here, for example, we'll start by showing the workflow. First of all, it's taking the input from you. And here, taking the input, I mean the script that you will use in order to build and encapsulate your packet. So, for example, let's say you will give an ASCII characters, and this is actually the way to do it, because you want to execute commands. Then, after taking the ASCII, it's actually doing something called the stealth encoding. The stealth encoding is not actually limited to like a specific part or a specific encoding technology or something like that. It's just encoding it with any algorithm you want. For example, here I just used ROT13 for a demo, but surely in a real operation, I will definitely create my own algorithm. Maybe just a combination between two algorithms or something like that. It's only about you and your thinking and even your mindset. So after encoding, for example, let's say who am I or PWD will be just encoded to an ROT13. And then the shareability encoding. And this one here is the point. It's actually the whole point and the core of this algorithm or of this technique. Because here, after having the ASCII codes, after the encoding, which is still encoding, we have to give it a specific data representation that can be transferred. through the window TCP flag. For example, here in the window TCP flag, we only have to provide integer values, the decimal base 10 values only. So we cannot simply just put some data like an ASCII characters, etc., etc. It's gonna literally disrupt everything. So we need to make our command shareable. We need to make our command actually transferable. So to do it, we must convert it into the equivalent for the same data type and data representation inside the window flag. And to do it simply, we just encode it into decimal base 10. After like encapsulating the packet, etc., etc., we'll just simply craft it and send it through the network. So simply, there is no actual connection here. You are just going to send it through the network. But from the other side right now, from the receiver side, and by receiver here, I'm surely referring to the victim, a Python script as well will be listening there through the whole network. So, for example, here in the network or the receiver, I'm simply using combination of algorithms or steps. The first step simply is so simple. Just running TCP dump with a privileged user here, and then listening for a specific packet. And with a specific packet here, I mean, for example, packet with a specific destination port, for example, or source port. So simply, so simply by finding a packet with that specific destination port, okay, it will be much easier for us to just highlight our packet to the script in the whole network because bunch of network packets will be in an infrastructure. So you need a way to highlight it. So for example, here in my code, I decided just to highlight it by the source or sorry, the destination port. So for example, here, the destination port 3451, okay, is not related to a specific service, etc., etc. So I can use it here as just like a highlighter for my packet to be parsed. So after simply receiving the packet, okay, a regex phase will start to literally ignore everything in the packet and literally ignore any unnecessary data and just extracting the window flag value. So the window flag value will be extracted in order to be parsed. But now we are first decoded from the shareability encoding, which means simply, first of all, we'll start decoding it. We'll start decoding the decimal base 10 first. And why I'm highlighting this here, because simply, if you still remember, we started our algorithm by doing the stealth encoding first and then the shareability encoding. But when it comes to the decoding process, it's so different because if you just give it a thought, okay, first we were having an ASCII and we wanted to make our ASCII text like decimal base 10. So, and to give it like more stealthy or more stealth, so even if it's actually have been decoded, it will not literally give any value. So we just convert it into another ASCII representation, which will be ROT 13. And then after that, to make it shareable and actually to make it transferable into the window TCP flag, we just encoded it into the actual or the legit representation of any window TCP flag in there, which is simply here in our case inside the window because it's only taking integers, specifically decimal base 10. We simply converted the character into decimal base 10 here. But now, from the decoding side, you must think about it in another way. So here, for example, you will actually notice that we are receiving it as integer already. So, sorry. So simply, we have to first decode it from the integer value, which is here 99, for example, in our image here. And then after having the ASCII representation for it, decode it from the ASCII representation based on our algorithm. For example, here it's going to be ROT13. So after decoding it from the decimal base 10, we'll convert it again from ROT13 to its representation. And in each character we will receive, we'll store it in a value in memory in order to execute it later using subprocess. So simply, this is the whole execution life cycle. You are simply taking a simple ASCII, a simple command. Let's say who am I or PWD or LS or anything. Okay, anything you want, literally. Then the stealth encoding will happen. And here the functionality for stealth encoding here is simply to avoid given the security analyst, for example, the way to know what we wrote actually here, because simply even after decoding it, it will be just a random character or random character from the security analyst perspective, but from our perspective, it's simply an encoded character. Then the shareability encoded, we are simply just using it in order to make the representation for our command or our character in a way that the window TCP flag can accept. And simply, we are going just to spread it into the network. And all the specific devices will think for a specific, or will just like search for a specific destination port, for example. You can also develop that script in order to make other indicators, like, for example, determining a specific IP address, etc., etc. But to be honest with you, here I implemented it through the destination port because if I just specify the IP address, and let's say someone detected us from inside the machine, the IP address will be literally the first indicator of who are we. But now if I just specified the destination port, literally nobody will know who sent that, except if just like a deep analysis of the TCP packets actually happened. And here inside actually the commander script that will be run from the attacker machine, I added a functionality to also manipulate the source IP address. So we can even manipulate it. For example, we can just spoof an IP address and simply manipulate it. Okay. So simply a lot of stuff that you can think about just to avoid being detected can happen here. But from just like a simple perspective, I just decided to make the packet highlighting for extraction and data exfiltration based on the destination port. You can surely convert it to make it, for example, the source port, because the source port in most cases is just like a random thing. So if you just made it like that based only on the source port, you can also you can also make it more harder because destination port here will be something, okay, making the developers say, okay, so this may be like a specific service or something like that. So we need to block the whole port that is simply like 3451. But if it was a destination port, but if you give it a thing from a source port perspective, okay, they cannot be blocked because the source port is randomly chosen by the device or by the network device, which means this can cause major problems inside the network because now let's say me as a security analyst just blocked the port 3451. Then let's assume a machine choose the port 3451 to initiate a communication to another host, and we already blocked that port. So how can we fix that if we already blocked it? Okay, so it's just like brainstorming you can do to just like think how can you make it more stealthy, but from the compromised host side. But from the network side, literally nobody will even think that the window TCP flag is something malicious or something we should like seek for any signature for it. Because, for example, let's see if the 99 here is a representation for an ROT 13 character. That is, for example, let's say it's the B character here. Okay, for PWD. So, okay, this is gonna be a signature. I'm just simply gonna block it. Simply, this will not work because what if the data or the payload size here is simply equals to 99? Okay, maybe you may also think, okay, what if it's just like data sequences? For example, if 99 packet window packet came here, and then the next packet will be, for example, let's say the next representation for the character W in ROT 13, but in base decimal 10. So that means there is a command being executed here. Also, this will not work because simply I can make another algorithm to, for example, skip the second or the third packet, or to create like randomly chosen encoding algorithm for each character, and the same for the recipient or script here. Okay, so it's just gonna be an infinity loop because this is like unsolvable problem every time you will do an implementation to something like the window or TCP flag or any something or anything that you think it's completely normal, and nobody literally will think that it may be poisoned. Okay, it's gonna be easier to bypass. Now here, as you can see, the known techniques of exfiltration, for example, you compromise a machine, maintained access, escalated your privileges, but simply will get caught. Transfer your data through DNS, for example. A lot of signatures are actually there. It's actually the first place that security analysts and even security solutions and appliances are actually seeking for, because it's so known right now. It was being used for ages, but nowadays you need a smarter solution. For example, here it's an example for the exfiltration part, and here for the exfiltration, I'm surely talking about the file exfiltration or the data exfiltration, not the commanding stage that we are talking about. But now, from another side, when you come to escalate your privilege and now you are actually ready to exfiltrate your data, sorry. So here, for example, you are inserting or injecting your data into a specific tiny part into a single TCP packet, which is simply already encoded and converted into the data representation that should be there. And also you can make it tricky. For example, you can evaluate how much the decimal base 10 value will be after injecting it. And then you can just add random data inside the payload that is actually the whole sum of this payload will be equal to the representation of that window size. You can even make it tricky like that. You can develop it and make it like that. And simply there is no even interaction here because, as I told you before, there is no actual interaction with the host. What you are actually doing right here is you're actually simple is you are actually simply transmitting your data through the network, okay, using a random destination, for example, etc., with a window size in which the machine that is actually compromised is the only machine that knows what port or what source port or destination port you will be sending this data from or to. And simply, this machine will take the window TCP flag or the whole TCP flag, then parsing the window size value, and simply execute it after decoding it from the algorithms. So it's simply the ideal way to transmit or even to consider during a red team operation, for example, or even if you want to implement your own C2, for example, framework, you can seek for the ideal way to put it in your tool in order to make your traffic hidden. Okay, now this is actually from a larger site. Okay, so Here we have actually multiple stages. So here, first of all, we have the compromised machine. Okay, we compromised it already. Then we escalated our privileges, and here the privilege escalation is a crucial part. And simply the reason here is we are going to communicate, we are going to deal with the raw network or the raw sockets of our operating system, which is simply will require us to have a high privilege because like manual crafting for the TCP packet will be there. After escalating our privilege, persisting, then we'll have two stages. First of all, getting the WCE tool deployed in the machine, preferably deployed as a service. Then we'll have the receiver.py because simply here in the victim machine, we'll be the recipient of the commands. So we should use the receiver.py script here in order, for example, to determine which interface should we listen on, which let's say, which port should I expect the data, the TCP packets to come from, etc., etc. Then in the sniffing here, we'll simply start sniffing the whole network with the specific packet specifications that we'll actually do, but from the attacker machine. Because, for example, from the attacker machine, we are the people who determine which port or which destination port or source port this packet will be sent from or sent to. So if we are going to the attacker machine, we'll be already having WCE tool there. We'll use the commander script, for example, and then we'll store the stealth encoding. And our stealth encoding here will be surely ROT13. We can simply do it with, let's say, ROT14, ROT11, ROT12, etc., etc. We can literally do it with any algorithm. You can even use a combination of algorithms. You can do it like in many ways. You can do it literally in many ways. You just do it as you want, okay? The most important thing here is just to make it legit and at the same time shareable. And by shareable, I mean convertible, for example, to decimal base 10 in a small piece of data that cannot, for example, be so large. So the packet could be considered, for example, as a denial of service attack or even like exploitation for a specific network level vulnerabilities attacks as well. So here, after just encoding it with the stealth encoding mechanism that we'll be using, and surely it's gonna be ROT13 here in this demo. So then we'll encode it with the shareability encoding. And here we are simply converting the data into decimal base 10. And as I mentioned before, we are actually doing this because it's the only data that can be accepted inside the window TCP flag. Then the window flag here, okay, will be crafted and injected into a TCP packet in order to be sent through the network. It will be actually spreading into the network. So simply here, after spreading it into the network, literally, there is no specific destination will be there. It's just maybe like a random packet, a dummy packet. You can even call it a zombie packet. There is no specific destination to go to. It's just gonna be simple packet just sent through the network. But from the sniffing side, in the victim machine, specifically with the regex, the packet will be captured from the network. And after capturing the packet and through the regex, the window TCP flag value will be extracted and then decoded from the shareability encoding for sure to be, for example, decoded from the decimal base 10 to an ASCII, but surely this ASCII is not the final data representation for us. So after decoding it from that ASCII representation ROT13, we'll store them all in memory and then execute them from there as a subprocess, for example, into the victim machine. So the whole process right now, if you just now look at it from this topology here, from a high level perspective, there is no actual connection between the two targets at all. Literally, there is no actual connection. And like this, you can simply exfiltrate data, command and control the data, okay, without having an actual connection with the victim machine. And this is simply just a showcase for the tool. You can see here, for example, the just like a simple implementation here. So here, for example, you can see that the remote device captured the rotated string right here, then decoded it and simply finally execute it here. Surely, because this is the demo version, you can see here, for example, output for, okay, this is the encoded command, this is the decoded command, etc., etc. But in fact, it's actually just for making it clearer for you how it works. But in a real engagement, surely you should make it silent without any outputs. Now you can see multiple stuff here. First of all, you'll see my Mac OS command line and my virtual machine here, which is Arch Linux based on AMD X64 by emulation. We'll just assume that here in the command line for Mac OS, this will be our, let's say, malicious device or our malicious, um, uh, let's say, the malicious node um, of our tool, or sorry, the malicious node of our operation, the whole operation here. Okay, so from this device, we'll command or we'll try commanding this device. And to do it, simply, we'll start repeating the process, but now in the practical ways. So first of all, I'm just gonna run the receiver script, but to run it, there are some specifications for the receiver script to be considered. First of all, you will need the interface, which is simply something logical. You are going to capture network packets, so surely you need to have the interface that's actually directly connected to the network. Then we'll need the packet count, which is simply the amount of packets that you want to capture, and after this amount being captured, no more packets will be captured or even saved. And the port here is simply the port that the data should be sent to, aka the destination port. So first of all, let me simply pick up my network interface here, which is simply going to be simply, it will be ENP 0S1 here. And then the packet count, I'm just going to make it 11 or 12, etc., etc. And then simply the port, let me make it like 8923. Okay. And here from this side, okay, we'll run the commander here. Okay. And here the commander, you may wonder that you have the target IP address. And the reason actually for having the target IP address here is not just for like specifying an IP address to receive the packets, it's just to route the packets to the network node or the network subnet that is actually connected to the network. Because, for example, some devices, when having like let's say a network share a network infrastructure, okay, some devices may have more than one IP address with more than IP class. So by specifying the target, you are actually specifying the class, or you are actually specifying the layer or the zone that you will be spreading this to. So here, for example, I'll just specify the command, which is going to be, let's say, who am I? Okay, or even PWD, no matter. Okay, and the target this is just like a single machine. There is no actual network in there, so there's nothing to route the traffic, etc., etc. So I'm just for this demo, I'm just gonna put the same IP address. But surely, when you have like your own setup, etc., etc., you can use um, another IP address, for example, other than the victim's one, and it will work. And then the destination port, which is the port that should receive the data, will be, for example, 8923. And the delay here is simply because there is something tricky here. When you actually send in data or even exfiltrate or executing commands or even exfiltrating data, it's a little bit tricky because simply sometimes if the rate for your packet sending is so high, for example, there is no delay between each packet, this may cause wrong or inaccurate TCP packets arrangements. There is no specific right order to be like to be received into the target machine. For example, the target machine may just receive bunch of packets in very, very few seconds that even the network is not capable to handle it, which means simply that the network will not send it in the right order and it will be finished and ended with you having wrong commands sent into there because of the lack of arrangements or packets arrangements. So simply, I'm just gonna put the delay here to be 1 second. And the source port here, I'm just gonna make it any source port. It's not gonna, sorry, the source host is not, it's not gonna be different. And the port here as well can be something like, let's just make it as like the same as destination port. It's not gonna be a big problem. And just to make it legit, I'm just gonna put a different IP address here just to make it like to simulate as it's the gateway for this machine. So to run it surely, as I mentioned, we must run it as a root user here because we must have high privilege here in order to be able to in order to write into the row sockets. Okay. So dash P, I think there's something wrong in here. Oh yeah, it's just okay. So now as you can see, the commands are actually being sent, and here every command have been sent here in a separate packet. Okay. And finally, this was the encoded command, and this was the decoded command, and this was the execution for the command. And simply, this was the practical demo of the tool. If you have any additional questions, you can ask me now, or even you can like reach me out in any of my social network or even Discord. Um, um, or even Discord account. You can I'm actually inside the West Hackin Fest Discord server. And yeah, thank you.